Alright, in this video we go over section 8.4, area of a triangle. So this section is going to be rather very short actually. So in this case, well, let's recall that the formula to find the area of a triangle is 1/2 times the base times the height. Alright, but now in this case, the information that we're going to be given to find the area of a triangle is going to be side angle side, in which the angle is going to be the one between the two sides, or the area of triangle given all the sides. So this formula is not going to be exactly useful for that end. Well, it's going to be similar, but it's going to involve some trigonometry. Well, the proof for this formula is not. I'm gonna skip it for now. I'm gonna skip it, and so these are the three variations of the formula. Notice we're using K for the area, even though the A is a symbol for the area is A. But the reason why we're not using A is to avoid confusion with the angle A. Alright, so let's see. Find the area K of a triangle for which A equals 8, B equals 6, and C equals 130. Notice in this case we're given sides A and B, and the angle is 130. So something like, something like this essentially. Let's see. 1 second. All right. So, well, it is 180 degrees, or actually there's a little typo. It's just 30 degrees, not 180 degrees. That's why I was a little bit confused. Okay, just 30 degrees. So essentially, we have something like, we have a triangle that looks like .30 degrees, but we're given the sides that are covering this angle, so 6 and 8. So we're going to use this formula. K equals 1/2 AB sine of C, which in this case that's 1/2 times A, which is 8, times B, which is 6, sine of C, which is 30 degrees. Alright, well, if we simplify this, what's sine of 30 degrees? Well, sine of 30, that's 0.5 or 1/2. So that's 8 divided by 2, that's 4 times 6, that's 4 times 6, 24, times sine of 30, which is 1/2, that's 12 units squared. Because keep in mind that this is area, so the units have to be squared. So that's one simple example. It's very formulaic. Well, just be mindful of the letters that you are given to fit the form for the formula. Now find the area of SSS triangle. So in this case we are given the three sides and none of the angles. And in this case, we're going to use the formula K equals the square root of S times S minus A, S minus B, S minus C, where S is 1/2 of A plus B plus C. By the way, this is known as the semi-perimeter. Why? Because, well, we're adding the three sides, A plus B plus C, which is the perimeter. Divide that by 2, then that has to be the semi-perimeter. Also, this is also known as the Heron's formula. And that's named after the mathematician Heron of Alexandria, who came up with this formula. Well, alright, so let's find the area K of a triangle whose sides are A equals to 4, B equals to 5, and C equals to 7. Okay, since the formula involves the semi-perimeter, we need to find that first. S equals 1/2 of a plus b plus c, 4 plus 5 plus 7, and that's 4 plus 5, that's 9. 9 plus 7, that's 16. So 1/2 times 16, that's going to be 8. Alright, so now using the formula k equals the square root of s, which is 8, times s minus 8, or 8 minus 4, times 8 minus s minus b, or s minus, or actually 8 minus 5, times s minus c, which is 8 minus 7. So that's k equals to 8 times 8 minus 4, that's 4, times 8 minus 5, that's 3, and 8 minus 7, that's 1. So let's multiply these numbers inside of the radical. 8 times 4, that's 32. 32 times 3, okay, 32 times 3, oh actually, times, that's a 96. So we're going to have the square root of 96, which can actually be simplified. Let's 96 divide that by 6. That's going to give us a perfect square. That's the square root of 16 times 6, which is 4 root of 6 units squared. But of course, if you want to simplify this, that's the second square root of 96. I mean, approximate to 9.80 unit squared. But most likely in MyMathLab, you are going to be required to, you're going to be asked to put this as a final answer. And well, so this is the end of this section. Again, like I mentioned, it's very, very short, just this couple of formulas. I'll see you in the next video.